Hey, Monaco and Milks, lecture 3 in our
Back at it.
study.
Like relentless.
Mm-hmm. Physical behavior and matter. We're going to hit up the types of energy, heat, and temperature so that you can distinguish between the different things, energy and temperature, how they're not actually the same.
No, they are not. And you'll be able to convert between the units of temperature using the equation on table T, which is on the back. Pretty easy.
I'm going to get one of those so we can practice later. Hit it.
Oh, got it. Cool. All right, so check it. Here's some gas particles in a closed container moving all around. They have what we call kinetic energy.
Yep. It's energy that causes molecules to move.
Like literally, heat is energy, pure energy.
And the type of energy it is, it's the type of energy that makes molecules move.
Right. And so this is something that we should inherently know, right? If I have something, it's moving, and if I heat it up, it's going to move faster.
There it is.
That should be, yep. If you didn't know it already, you know it now.
Now, it does contain 3 types of motions because when those things are moving around, they could do one of 3 different things or all 3 different things at the same time.
Depending on how much energy it has.
Number 1, vibration. All atoms are vibrating in place. They have a vibration. Wobbling back and forth.
This desk is vibrating.
But not spinning. They're just kind of humming in place.
Yeah.
Okay. They can also move from point A to point B.
Yeah, this is like you guys changing classes. You're literally going to move from one spot to another, right? Mm-hmm. That's translational.
Now, atoms vibrate as they do it.
Yes, they do.
They go from one place to the other as they vibrate.
Yeah, I didn't put these motions in order.
Mm-hmm.
The rotation would actually be 2. Should have been 2.
Doesn't matter. It's all order. They could also roll. So they're vibrating and rolling and moving in different directions.
Sure. So this is spinning around an axis, if you will, like the Earth. Rotating and revolving.
Right.
Revolving would be the translational.
Sure. And then it vibrating in place would be the vibrational. So all atoms and molecules are doing all 3 of these at the same time.
True.
When we're talking about their kinetic energy.
Having total energy, not just the freezing point and boiling point of water. Setting us up.
Okay. Potential energy is kind of an energy of position.
Yes.
Okay. It doesn't take into effect that, you've got rotation, vibration, and translation. It's more like this piece of paper could fall. It has the potential to do so.
You have to add energy to raise it up.
And now it has more energy than it did before, potentially. Right?
It's stored.
It's got more energy now than it did here.
And that's really the physics definition. And we're going to talk about it in phase. Mm-hmm. So solids versus liquids versus gas.
Right. Which one has more stored up energy?
Right. There you go. So heat versus temperature.
Well, heat is kinetic energy. It causes atoms to move. So we can say that it is kinetic energy.
Yes. And then temperature is simply just the measure of average kinetic energy.
Right.
So we can't get those 2 things confused.
No.
And it's easy to try to link them together.
The kinetic energy causes the temperature thermometers, the liquids, to expand because energy causes things to move. So that little red line or blue line in the thermometer expands when it gets warmer and moves up. And we've just put little marks on it to say, oh, well, that's this many degrees, which is average temperature of the molecule.
Now, this is the piece we need to know fundamentally. Heat always flows from hot to cold. So in the question where it talks about heat flow, just find out where the hot thing is, find out where the cold thing is, and it always goes from the hot thing to the cold thing.
Doesn't matter how heavy the objects are.
Nope.
Right? One might be like 100,000 pounds, one might be a gram. But if the gram is hotter than the 100,000 pounds,
there goes
heat goes from the gram to the bigger object.
That's
hot
always
to cold.
You cannot break this law.
Mass has no effect on it.
Nope. And there's nothing we can do to fix it. It's going to happen.
Mm-hmm. Absolute zero theory is a cool theory, and it is a theory because we have not achieved it as scientists. It's the temperature at which all motion stops.
So that translational, the rotational, and then even the vibrational, which would be the last of them to change or to stop, finally ceases.
And the tough thing about this all motion stops is that the subatomic particles are even in motion around an atom. So achieving absolute zero would require humans to make all motion stop, like suck away all the energy from an object, and we just haven't been able to do it, even at the quantum level.
Right. And so this little picture of the temperature scale is really good. There's a piece similar to it in our practice packet where you can check it out. And notice it's taking the exact same temperature and showing you what it is on all 3 different scales. Mm-hmm. We're only concerned about Celsius and Kelvin. Now, the thing that Celsius does do that Kelvin trumps is Celsius is just based on the boiling point and freezing point of water.
Right.
So like where that transitional motion of the water and the rotational motion of the water molecules stops. And then they still have the vibrational motion though. So they still have some latent heat is what we would call it, even though it's frozen now and it's solid.
Yeah.
So Kelvin is going to now expand into all total energy, not just the energy of water molecules.
Yes.
And so it's more absolute. And then it helps us deal with these heat transfer type equations.
Things that are either extremely hot and extremely cold as well, when Celsius doesn't really make much sense. With Kelvin, you don't have a negative degree.
Ever. That's
Ever.
another cool
The negative sign, when he was talking about math, negative signs in math screw people up. Well, Kelvin doesn't have negative
No
signs.
such thing.
So if you use Kelvin temperatures in your calculations, you'll never make a mistake related to a negative sign.
Correct.
If you use Celsius by accident, you're going to get weird numbers and be like, how could there be negative heat?
Right. Well, we technically can't have zero in the denominator with kelvins either because we don't have absolute
Zero.
Right.
Exactly.
So temperature and kinetic energy, remember, heat is energy. So in this case, specifically kinetic energy.
Yep.
Heat is energy. Say it with us now.
And temperature is simply the measure of that average kinetic energy. So it's measuring heat with a degree, but degrees are not the same as heat.
Correct.
It's an indirect measurement technique.
Yes, it is. Okay, so we got to do some of these.
Yeah, I'll get the
All
pencil
right,
up.
sweet. So we're gonna. This is a clip right off of table T. So I got this equation: K equals Celsius plus 273. So we're just gonna plug and chug. If I get a 0 degrees Celsius, plug it in. You add 273, and 0 plus 273 is sweet.
There it is.
Okay, now we gotta erase and do 100.
Oh, yeah. Oh,
So you're gonna plug that right in. So it's gonna be 100 for C plus 273. I can do that off the dome, Monaco. 373. Sweet. Oh, here we go. Now is where things were getting a little crazy. Negative 273 Celsius. A negative 273 plus 273 gets us to 0 kelvins.
Not okay. 0 Kelvin.
Yeah, not okay. That is a 0. Good call. Good call. Now we can go the opposite way. We're still just plugging and chugging. I have 273 Kelvin, so I'll plug that in on the Kelvin side. Now I'll have to subtract 273 to get my Celsius. And Monaco just put an X in for Celsius, which is fine. You can put a C there or an X, doesn't matter. Just we're solving for Celsius, which in this case is not okay. It is 0 degrees Kelvin. I misspoke. Kelvin is not degrees technically. It's 0 kelvins.
0 Kelvin equals
Oh, yeah.
X degrees Celsius equals 0 Kelvin in that case.
Oh, yeah. Well, 0 degrees Celsius is the actual answer.
Yeah, that's right. 0 degrees Celsius. Mm-hmm.
Yeah.
Next one.
Yep, 373. So we're solving for degrees Celsius. So we got degrees Celsius plus 273, subtract 273 from both sides, and we get 100 degrees of Celsius.
You know why I messed up my units on that one? Because I didn't put them in the first one.
Yeah, you put in the X and it did it. You put in an X for C and it got you all messed up. But that's what it's all right. 0 degrees Celsius. Perfect. One last one.
So measuring temperature, it's pretty easy. You put a thermometer in it. Converting it to Kelvin is also pretty easy. You add 273 to it. And going to Celsius from Kelvin, you just take 273 away.
Yeah, you're literally just plugging and chugging in this simple equation. Let's not overthink it.
Heat, not the same as temperature.
I got a feeling you can do the practice on this part by yourself.
I hope so. See y'all later. Clicky button, turn off the video.